Okay, let's go ahead and take a look at how we want to apply exponential functions in graphs. One of the things that we can do is we can always look at exponential growth and decay. Now, if we talk about exponential growth and decay, we're going to go ahead and take a look. And notice that if we talk about exponential growth, we're talking about as x increases, then the value of f of x is actually increasing at an exponential rate. Okay? In the same respect, when you talk about exponential decay, the value is decreasing at an exponential rate. And it's all going to be based upon the function that we just looked at in the previous lesson. This most general form here of f of x is equal to a times by b to the exponent c plus d. So we'll look at some examples as to how to actually use this in particular contexts so that we can figure out exactly what is happening and why those are going to be considered exponential functions and exponential growth or exponential decay. Now, one of the things that I'd like to also go ahead and bring back, because this is kind of far back from last year, is recall geometric sequences. If you want to make a connection here, remember we said that u sub n is going to be u sub 1 times about r to the n minus 1. We said that u sub 1 is going to be the initial value, which in this case is very similar to what the a is for the most general form of our exponential function. This is going to be the initial value for your geometric sequence. We know that n is going to be an element of c positive because the first value for n was 1. And then it goes to 2. And then it goes to 3. And then after that, we know that this r value is going to be the common ratio if we take the u sub n plus 1 and we divide it by u sub n, and that will be constant for all of the values that we have for that particular geometric sequence. So all geometric sequences, really, if we take a look at it, is another form of an exponential function. But there's one primary difference between that, and you need to make sure to keep this clear in your mind, is the domain. Remember that we said that with u sub n, domain is n is an element of the positive integers, whereas x is going to be an element of all reals for the exponential function. So what that means then is that if we actually go ahead and graph this, remember we had dots, because the only values that you could actually place in for n was 1, 2, 3, 4, 5, and then the associated u sub n value. So that means that you're coming out with dots, dots, dots. On the other hand, when you take a look at the exponential function says that the domain is x is an element of the real numbers. So notice that it's going to be a smooth curve. It can also be negative, and it includes all of the values in between the integers as well. Okay, so we'll go ahead and take a look at a couple of applications to make sure that we know how to use this. But it's going to be important for you to also go ahead and recognize that the exponential function and geometric sequences are very similar, with the main primary difference being the domain. Okay, so we'll take a look at that. We'll see how everybody does in class the next time that we meet. Okay, see you later. Bye.